it wasn't until A, telescopes got better, and B, we managed to get close enough with a spacecraft that could resolve that, you know, what he was seeing and making out his patterns were actually just natural features that didn't quite fit the pattern he was drawing on top of it. The other big excitement about life on Mars came in the 90s when a scientist found a meteorite in Antarctica that had come from Mars. Now, you might ask, how do we know it came from Mars? Right? Well, we know it came from Mars because of its chemical composition. Its chemical composition is similar to that of Mars and dissimilar to that of asteroids. So this is probably a piece of Mars that got hit, you know, from a large asteroid impact that hit Mars and kicked up rocks into space, and one of them ended up on Earth. This is not the first meteorite we've ever found that came from Mars. We found more than one that came from Mars. In this, there are these little structures like this, and there are a bunch of them in this meteorite that got some people at NASA extremely excited because they look organic. You know, they look like that could have been some sort of bug, or by bug I mean bacteria. But we can't really tell if that was once a bacteria that's been fossilized, or if these are just natural minerals that formed in this shape. So this is one of those things we've not been able to answer, but it's one of the things in the 90s that everybody excited about. Well, we need to get to Mars and we need to start taking more samples to see if we can find any microbial life on Mars itself. Okay, so lined up all together, right? Mercury, and you can see in this picture, is a great one to see that Mercury's nickel iron core is really close to ours and Venus's compared to its size, you know. And there's the moon, there's Mars. Why are they so different? Well, no atmosphere, acid atmosphere, free water, and CO2. All right, our atmospheres are completely different. If we look at the sizes, relative sizes, you know, Mars, Earth, Venus, Mars, Mercury, the Moon. This is our sizes. And this pretty much sums up what we're up against in terms of atmosphere, right? Here, no. Here, 96% CO2. Here, mostly nitrogen and 21% oxygen. Here, mostly CO2 with some nitrogen. Now, one of the things about Earth's atmosphere, when we look at these and you say, wow, these are so dramatic, why are we mostly nitrogen with some oxygen, and this is CO2 and that's CO2? And the answer lies in what happened on Earth about 3 billion years ago, when small bacterial life forms began taking CO2 out of the atmosphere. So we actually had bacteria plant life, right, that began taking CO2 out of the atmosphere. And there came a point where everything flipped on the Earth, and we flipped from a CO2 atmosphere to an oxygen atmosphere. And this happened because of microbial life forms. And we made that transition as they began tying up CO2 in things like the seashells you pick up have a lot of CO2 in them, right? So sea life began tying up CO2 in a lot of mineral deposits that they were making and just simply taking it out of the atmosphere. And as they took it out of the atmosphere, we began converting over to a nitrogen-oxygen atmosphere, and then we reached a point where the predominant life flipped from consuming CO2 to consuming oxygen. Questions?
No questions about that.
Huh?
About anything or about that?
About anything.
I got one for you. flip back to chapter 8 though.
Okay.
So one of the questions on the quiz was about the transit method. And you know, in the book it says that it favors finding planets that are very close order to their stars.
Right.
But I got that wrong on the quiz. It says they answer correct with very massive planets.
It's probably both. Shoot me a note.
And also, you didn't change the grade for the chapter 9 quiz yet, so that will be done eventually, or is that?
Shoot me a note. I mean, it must have not automatically done it.
Okay.
It was supposed to, but something fell. Any other questions? Did me sticking equations in the homework help at all?
Kind of, but again, for the chapter 8 homework, Kepler's law for the last problem, you said it's in figure 8.8 in the book. Or
Well, you have the new book.
I have the new book. I know it's supposed to be 8.7, but is that in the back of the chapter questions? I still can't find explanations of that equation.
For Kepler's law, I'm not sure where the explanation is.
Me neither.
Okay, so I'll look again.
Okay.
I don't recall off the top of my head where the explanation is. So.
In the question, actually not taken from Canvas, but going back to the chapter, it says it's in figure 8.7 in the book, but I don't know where figure 8.7 is.
Yeah, and that's one of the reasons. That was what prompted me to start sticking in the equations. It was like, that makes no sense, right? And this book, so I'm, not that it affects you guys, but I'm talking with a publisher about looking at other books. Because there are some things this book does I don't like it puts information you need into figures instead of into the text. And so I'm looking to move away from this book because I'm not happy with how it delivers information all the time. Working our way up to the next test. Okay? Working our way up to the next test. There will again be 10, and if you have not seen me and I ask you to come see me, please come see me. There will be 10 multiple choice questions again. Now one thing about this last test that I don't know if you guys realized or not, but every single one of those multiple choice questions I asked, except for the one I told you I was going to ask about the sentence for the equation, every single one of those questions came straight out of the book. Alright? So that's going to happen again. All those questions are going to come straight out of the book. I'm going to give you a problem, among the problems I'm going to give you this time, I'm going to give you a problem where I'm going to give you all the numbers to stick into an equation and I'm going to ask you to calculate it. Alright? I'm going to actually give you the equation with the numbers in it and say calculate this. Alright?
Is it a trick?
It is not a trick.
So what's the catch?
There is no catch.
Okay.
There is no catch. Right? Here's what I need to know. I need to know how many are having trouble calculating stuff with your calculator, so I can sort out what's going wrong on the problems. So I'm going to give you a problem that is simply calculate this. Here are all the numbers. I put them in for you. Tell me what the answer is. All right? And that's going to help me know. Yeah, exactly. All right? And so I'll know then what else do I need to do. I already know that next semester I'm going to start off with a calculator lab. All right? I can't take the astronomy. All right. Any other questions?
What all is due tonight?
Huh?
What all is due tonight?
So I'm on the fence about Chapter 9 being due tonight.
You should be
We're about to be on vacation. Please.
You're about to be on vacation.
Please.
See, I don't get vacation.
You don't want to see us. That's what I was
I mean, as far as
You don't have to see us.
So watch Canvas. I will probably change that. That was kind of, things have been moving so much on Canvas because of our events of this semester. I've had a hard time. The great thing about Canvas, you get the whole semester set up, and it just sits there and it runs itself. The bad thing about Canvas is something goes wrong, now you've got to do all that work again. All right, of setting up the rest of the semester. And there's no easy way to simply say, hey, just adjust everything for me. So I will probably move chapter 9. I'll have to send a note to the online class because most of them turned it in last night. Any other questions? Concerns? Fears? Come see me. I have office hours. Use them. All right. I will publish the solution to 6, 7, and 8 sometime soon. Enjoy your break.
I came in about 5 minutes later, so I think I was.
You probably did. Let me just